additional barbering level mechanical engineering students.
And the title of my project is Development of an Automatic Solution Pump.
And my project title is Design and Construction of the Input of Manual Sheller. My name is my project title is Design and Biogas Extraction System from circuit. Well, my design aims to solve many problems. I'll start with energy, and the sense that what gas prices are constantly on the rise. Global warming is happening, right? And then we are sitting down on reusable gas, biogas actually, in our circuitries. So my design aims to bring the problem of using the renewable energy in the circuitries to solve our energy need in the household.
Okay, so for some medication administration such as intravenous NGSO4 in pregnant women who currently have preeclampsia, they are usually administered by setting specific or regulated dosages per time interval. These dosages are usually administered normally, especially in hospitals or clinics where they cannot afford these syringe infusion pumps. So the aim of this project is to actually develop a low-cost automatic infusion pump that is very affordable, user-friendly, and also incorporates safety mechanisms to make sure that people get the best healthcare experience.
Basically, the problem the tabletop manual sheller solves is problem of energy, because the manual shellers we have currently are of higher capacity. We have some of about 2 horsepower, 3 horsepower. Also, it solves the problem of bulkiness, because the manual shellers we have currently in the market are also heavy to carry around or move around. So we have them usually situated in the farms, and people cannot really move them to markets. Also, manual sheller, the tabletop manual sheller solves the problem of cost, because the ones in the market are currently around the price of about 360,000 naira, whereas the tabletop manual sheller, which is the proposed one, is about 35,000 naira. So it also solves the problem of cost for a low-income farmer or for household usage. Okay, the key challenges I first experienced was the fact that I needed to scale down an existing model, which is of a bigger size, to a very small model, and still maintain similar efficiency, which means that there is currently non-existing tabletop manual sheller, and which means that I do not have a specific reference to follow. And now here is me trying to scale down a very big model into a small model. So I encountered the problem of design calculations, efficiency calculation, and then structural calculations.
Okay, so some of the challenges I encountered were majorly during the development process, which was in terms of microcontroller. Because I was using stepper motor, I also had to use a stepper motor driver. And most of these products that are available within our immediate environments are actually from China. So most of them were getting, should I say, spoiled or burnt during the development process. So I had to keep buying. But in the process of buying some of them, I was able to realize that some of them are more reliable than the other. And I think those are some of the things I've learned so far during my prototyping stage.
Okay. In designing, I think one of the challenges I experienced the most included just the feasibility of the project, in the sense that it was something that people were not really comfortable talking about and even exploring further. But I mean, if you have an idea, you can't stop. So it was resilience that I put into it. I had to do my research across the western side of Nigeria and also outside Nigeria to look at the feasibility of the project. And yeah, that's how I'm working it. Yes, initially when I started this project, I was only thinking about building the model, just me achieving my efficiency and then getting into others. But when the whole competition thing came in, and then we have to talk about the scalability, the impact in the economics, and then the viability of it, and the feasibility of the system. Then I started to think about the cost of production for producers and also the cost effects on consumers, which means that I'm no longer just dealing with the engineering aspect of it, but now I am dealing with the business aspect. So this is me working on 2 models at the same time.
So yeah, participating in the LEEDS initiative competition actually really gave me more insights, because it's made me actually dig deep even deeper than I thought the project was actually about. So it made me really, really go into the project. It's also the feedback from the judges, the feedbacks from every round also improved my knowledge, also made me able to think further than I had initially thought about the project. So my participation in this project has really, really enriched my experience building this project.
Right. So participating in this competition actually influenced me in multiple ways. The first one, being that engineering is a very serious business in the sense that you can't just choose and guess and try to do something that would work. You have to be very direct about your things. Are your measurements correct? Are your pipings correct? And also for entrepreneurship, in terms that you can't just go people and say, oh, you have the brilliant idea, come and buy it. Like you also have to convince them, how much it costs, what it's going to look like, how it solves their problem. And yeah, these 2 points have actually stuck with me throughout the competition. Right, so one of the feedback I got during competition, I remember because my system is a closed system, right, wherein that once it's launched, you don't really need to add anything from the inside, you just get our output gas. And I remember one of the judges asked me how, if you want to add things from the external, how do I plan to incorporate that? And I had to, make room for it in my design by creating an external shoot, which you can put some digest it in. So yes, thank you.
Yeah, so I remember during my round 2 presentation, I had a 3D model, and one of the judges actually mentioned that I had to do like, should I say label, like an engineering drawing, like this engineering drawing that we did in TLB 101. He actually mentioned how I had to label and do like a very detailed design of my, should I say very detailed dimensioning of my design. And I think that really, really helps, because it was at that point I actually realized that although my design on the outside was really, really beautiful and really fine, but some of those things could not actually pass the design test. So yeah, that was it for me.
Yes. One of the questions I was asked during the competition was that what would be my attraction towards an average household user who does not really consume egusi soup, because my project is tabletop melon sheller, egusi to be precise. So if egusi seed is not being consumed as a soup in some specific homes, then how do I sell the products to them? And then I came up with the idea of byproducts, which means that what other products can I use the egusi to make, the egusi seed to make, apart from the egusi soup? And then we can talk about where we have egusi cake, where we have egusi milk, where we have egusi oil. And before you can achieve all of this, you need to shell these seeds first. So which means that now an average user who does not even consume egusi soup or does not like egusi soup can still use the egusi seed to produce other food items that can be sold, thereby encouraging entrepreneurship.
Okay, so for me, I would just say that you should keep trying and participate in competitions like this, and also do not give up, because I remember like I said earlier, for my challenges, when my microcontrollers kept burning, I felt like, oh, probably this project wasn't even going to work, or it wasn't even going to make it out of this prototyping stage. But I still kept on researching on more, or should I say better materials that I could use throughout the process. So I'll just say that don't give up on your engineering dream, or whatever you actually dream of coming up with for your projects.
Well, I would say that number one, don't be afraid. Right, don't be afraid. Number two, be very exact with your words. Be exact with your words. Be exact with your dimensions, your drawings. Let things be as transparent as possible. Don't try to cover anything up, in your design. The advice I would give them is that as much as you are thinking about, achieving an idea or coming up with an idea, you also have to think about the time factor. The world we move in right now, it's focuses a lot more on time. You have to find your solution as fast as possible, because in the course of the competition we had the time frame, which means that I needed to produce the device within that time frame. So I would say, for intending engineers, don't think you have 5 years, 10 years, 20 years, and then you don't sit back and then start relaxing while producing. Instead, think about how fast you can produce a device. At the part of this competition, my design career actually revived. The thing where I was kind of going down, but being in the news competition, going through that process of designing, see your design comes to life, kind of kickstarted back to life. And I actually look forward to continuing designing
even after university days, as a career choice?
Okay, designing this model has given me that confidence that I can, come out with better ideas, and it has also opened my eye into the issues faced in the society. Because, for example, this tabletop melon sheller now, when I went to Bodija market, I couldn't find a specific place where we had a melon sheller. I was told that I had to go to Ishane. So which means that there are lots of problems that people are facing in our society, but it's until we ask. So it's poured me to ask questions, which in the nearest future, I'm going to be asking more questions and try my best as an engineer to make impact in the society.
Okay, so for me, one of the things I was looking to do for my project was to actually find an integration between biomedical engineering, mechanical engineering, and software engineering. So I think moving forward as well, that's still my career goal, which is to probably maybe pursue a career in biomedical engineering, such that I would be able to incorporate my knowledge of software engineering and the knowledge I've gotten from mechanical engineering in UI, bring everything together, and from there, kind of improve the state of biomedical engineering, or should I say biomedical equipment in Nigeria. And the overall goal is just to make sure that everybody has equal access to healthcare in the country.
Well, so it's a very exciting process, because I'm not going to lie. The whole course, we had about 3 stages: submission of proposals, we had the progress stage, we had different presentations that we have to submit, both soft copy and then the physical presentation, and then before the final competition. And I'm going to say that I was really excited that all of the efforts paid off eventually.
It feels great. It feels very great. That's what I can say. I saw the work that people put in. I saw the work I put in, and it feels like a privilege actually that my work was able to make it this far. Looking at how that it solves some problems, and I'm happy that I was able to get to this stage.
I would say it was a very, very challenging process, and it was such a great opportunity. I felt really, really happy to see that my work was actually recognized. Like, all of the hard work that I put into my prototyping stage was really, really seen. Like, I was able to still bring it to people that were not even there during the whole process, and they were able to see that, I was deserving of the second position, and it made my engineering dream more alive, kind of thing. Okay, so I think one of the things I hope that viewers are going to take away from this documentary is how we can actually make use of the, should I say, components and the resources around us to come up with a solution that we have to a problem that we have identified in our immediate environment. I think in my project, I made use of 3D printing technology. I made use of wood to improvise for some things that I felt were very, very costly. I made use of some low-cost materials as alternatives to the things that are being used in these modern homes that are actually very, very expensive. So I really, really hope that people take out the fact that you can actually solve problems from even a small place like UI.
I would say that you can do it. Honestly, that's what I was saying. You can do it. That's what I was just thinking. You can actually do it. Thank you.
Currently, I've been receiving a lot of messages from other students that, how did you do it? What do you think about this project? Can I see your proposal? Can I see your write-up? Can I see how this is? So I think my project in a way has encouraged a lot of people around me in my society to also support their own innovation, that if this is possible, they can also do something as well there.